Okay, so sorry about the delays. Welcome to the course. Let me first introduce myself. I am Ritviz. I am a PhD student working in IIT Madras, and I'll be taking this course as your online live session TA. Okay, there's another TA, the lead TA for the course, which is Bhaskaran sir, who will be available on the question and answer discussion forum of the course. Let me just point you to it. So on Swayam portal, okay, so this is your Swayam portal. This is how things look like over here. Okay, here you have your videos for every week that you must be going through. The assignments and the lecture materials will also be available over here. And there is this Q&A tab over here, right? So make a note of that, okay? And if you click that, it will lead you to a Google discussion forum. Okay, so many students miss out on this, so I'm just pointing it out at the start of the course itself. Here you can ask your questions and they will be answered by the lead TA, which is Bhaskaran sir, okay? And if there are any questions related to the live session itself, that I will be addressing either here or through the Gmeets or the live session directly, okay? So yeah, that's about the logistics. So yeah, I know there is a limit on the number of students that can be admitted. There only 100 students can be admitted to the Google Meet at a time, which is unfortunate, but the good thing is that this session is being recorded, and the recordings will be made available to all the students who are registered for the course, including those who were and were not able to join today's live session, so they can watch it at their own convenience later on. And gradually, as the weeks progress, the number of students who join the live sessions is typically seen to taper down. So maybe in a week or two things will settle down and all of you will be able to join the Google Meet. So don't worry about it as of now. If you're not able to join today's session, the recording will be made available to you in maximum a week or two's time, okay? So don't worry about that. And there are some questions on the chat box. Let me just address it one by one. So okay, so Mayank says he joined the course yesterday. So Mayank, this is mostly a course about this is leaning more towards theoretical AI or more simpler ways of addressing the problems that we usually come across in day-to-day life. So you will mostly be discussing search methods, then a little bit of planning and game strategies. We'll be looking at a bit of logic, and yeah, that's mostly about the course. You can also have a look at the outline that is available on the Swayam portal. That will be more thorough, okay? So each week we'll cover different parts of the course, different topics of the course, and for each week's content we will be having one live session, okay? So 12 weeks of the course and 12 live sessions plus an extra session before the examination if that is possible, okay? Depending on the NPTEL team, we will try to arrange that, okay? And in each of these live sessions we will be taking some problems, okay? These problems are problems that have been presented in the previous iterations of the course, okay? So these are problems that were there in the previous assignments or in the previous examinations, okay? And you will expect similar problems in your current assignments and the current examination that you might appear for at the end of the course, okay? So the aim of these courses is to help you guide to solve the problems in the most optimal way and show you some tricks and tactics to try to address these different problems. You can also feel free to ask your doubts over here, although I would encourage that if you can make me as the TA aware of the specific topics that you would like to be discussed beforehand, I can prepare questions that cater towards your specific needs, okay? So that is the plan of the course of the live sessions. So Professor Deepak will not be joining these live sessions. You can but he sometimes checks the discussion forum, so you can post your queries over there. Also, if you have any requests on the specific topics that you would like to be discussed in the upcoming live sessions, I would encourage you to post that on the discussion forum so that I can have a look and then I can prepare questions accordingly, okay? that is the plan going forward. But for today, we will be discussing some of the preliminary questions from the initial few very preliminary topics of the course. Okay. Are we going to learn any coding in this course? No, we are not going to cover any coding in the course, but we are going to learn several algorithms in the course that you can feel free to implement and try to test it out on your own local systems. That will also help you understand the algorithm, and that will also help you learn the implementations of it. The course itself won't teach you or won't go into any of the programming concepts, but we will have a look at some pseudocodes and certain elements of the algorithms that might be helpful for you to finally implement the algorithm itself. Okay, I hope that addresses your question. So those were the comments in the chat box. Before we get started with the questions for today, one more thing that I'm going to point out is that all the slides that I'll be using in this live session, those will be made available along with the recordings of each live session. Okay, so don't worry about that as well. We will be supplying all the resources to you. Okay, so before we get started with the questions for today, are there any questions that you would like to ask or any queries that you would like to get resolved? So there's a question that says, where can we use these algorithms? How can we implement it? So we will be mostly talking about, at least in the initial few weeks, we'll be talking about search methods. Okay, and there are a number of problems where you can apply these. Okay, a very simple example could be just figuring out whether you given a map. Okay, you want to go from point A to point B, right? And there are several ways that you can go to. You have to find the optimal path to it, right? That is one application. There are several popular problems in computer science, like the traveling salesman problem, where you can apply it. Even these are some of the things that we will be discussing in the course, because these are relatively easier to break down and go into the details of and understand how exactly the method is working or the algorithm is working. But it can be scaled up to even more complex problems. You can think of something like chess, which is a very complicated game, and you can even apply search methods over there. Okay, so the length and breadth of areas and problems to which you can apply the method that you will be learning in this course is very vast, and I would encourage you to kind of I gave you some examples. You can also feel free to look a bit up online as well, and I'm confident that you will find some interesting applications. Okay, a couple of more questions. No, so there's a question on whether we will be able to see the question answers of other participants in the live sessions. Yes, okay, because all of you are present right now in the live session. So if any of your colleagues prefers to answer, you will be able to hear him or her. But the graded assignments, you won't be able to see your participants, your colleagues' answers. After the deadline for each of the week's assignments has passed, the answers will be released. The answers will be released, but the solutions I'm not sure. For that, you'll have to ask Bhaskaran sir, who is the lead TA. Okay. Yes, you can expect similar questions in the assignments and the final exam. So there are a couple of questions about the implementation. Preetham, you can use any platform to implement this algorithm: C, C++, Python, Java, anything that you're comfortable with. And there's another question on where can you apply AI search methods in mechanical engineering. So I am not from that field, so I don't think I am well equipped to point you to problems in mechanical engineering that could be answered, but I'm sure there will be some things. And yeah, I think you can also ask that question in the discussion forum. Maybe we'll find you some domain expert from mechanical engineering who can point you to certain problems. No, the live interaction is not mandatory for every person to view, because it's an optional session. First of all, if you have any doubts, or if you want to know how to solve certain problems that you might encounter in the assignments, you can feel free to join the session. If you are not available, the timing doesn't work for you, you can watch the recordings on YouTube later on. Okay, so it's completely up to you. It's not compulsory. Yeah, I will point you to that discussion forum again. How is all this connected to deep learning? Okay, a lot of questions. Let me just first point you to the Swayam portal. So this is the Swayam portal, right? And this is the Q&A panel over here. Just click on it and this will lead you to this discussion forum on Google, or it's a Google group, and you can ask your questions over here. Okay, how is this connected to deep learning? So you can think of AI as a big set. Okay, I hope all of you are familiar with set theory at least, right? Sets, subsets, those. Can I have a show of hands of if you are familiar with that? Okay, great. Thanks for your responses. So you can think of AI as a big set. Okay, there are some traditional ways that we use to solve problems. Okay, those are the kind of things, simplistic approaches, heuristic approaches, bit of logic based reasoning. Those are the things that we will be discussing in this course. Deep learning and machine learning, where you usually deal with more pattern recognition kind of things, and neural networks and those kind of things, those are the topics that we will not be discussing in these live sessions or this course. There are other courses for that go into in-depth understanding of what exactly deep learning approaches are, or what really pattern recognition or machine learning approaches are. And if you're interested to explore that, you should enroll in those courses. This course will be dealing more with a bit of theory, a bit of simplistic approaches to problem solving. Okay. Yes, this live session will happen every week for the 12 weeks of the course, plus an additional session before the examination. So there's a question on assignments. Yes, you can attempt your assignments as many number of times as you want before the deadline. Okay, so every week assignment will have a deadline. Please make note of that. Post the deadline, you will not be able to submit the assignment. So before this deadline, you can submit the assignment as many number of times as you want. Is it necessary to solve week 0 assignment? I am not sure. If there is a deadline, please adhere to that and attempt it. It will also be beneficial if you ask this in the discussion forum, because I am only the live session. I am a TA for the live sessions. I am not in touch with the logistics of the course, about how the assignments are conducted, how the assignments are planned, how the examination is planned. I am not aware of that, so I am not the right person to answer those questions. It will be better if you ask those on the discussion forum, so that either Bhaskaran sir, who is the lead TA, or the NPTEL team can answer your queries. Okay. Okay. Does this course become placement ready or industry ready? I am not the right person to answer that. Again, I direct you to the discussion forum. Okay, so most of the questions I think are repeat of what I just said, or what I just answered. So with that, I think let's get to the questions for today. Okay, and we will mostly be dealing with some preliminary questions. Okay, that will give you a flavor of the kind of things that you will learn in the rest of the weeks of the course. Okay, first of all, I hope I am audible to everyone. Can you confirm that?
Yeah.
Okay, thanks for confirming, because I keep getting this message where I have unstable connection. So I hope I'm audible to everyone. If there is any issue, any lag, just point it out to me. Okay, and I hope my screen is also visible properly.
Yes.
Okay, great. So let's get started for today's questions. And please don't mind the 2023 date over here. It's some slides from 2023 offering of the course that I am reusing, but yeah, so I just haven't changed the dates, but the content remains same or valid even now. So let's get started. Okay, so one of the things that we will be encountering in the course is going from one state to another state given a particular domain. Okay, this particular domain in this question that we are looking at is basically it has boxes. Okay, the boxes are arranged in a certain way on the table. Okay, and imagine you have a robot with a single arm and a single arm only, who can manipulate the arrangement of these boxes. Okay, and you are given one particular arrangement, which is the initial state, and you want to follow a certain set of actions that the robot will do, so that you go from the initial state to the final state. Okay, that is your ultimate goal that you want to achieve, and you can only do that via certain specific actions. Okay, some of those actions include stacking a box on top of each other. Okay, that is called the stack action or stack operation. Then there is unstacking operation, where you remove a box from top of another box. Okay, another action is where you put a box onto the table directly, that is the put down action, a put down operation. And then when you pick up a box directly from the table, that is called the pickup action or the pickup operation. Okay, and remember, the robot only has one hand, and at a time it can pick up only one box, or put down only one box, or stack or unstack only one box. So that is the setting of the problem. Okay, so I think, having said that, I might have given you some hint towards the question over here. The question gives us an initial state and a final state, and it asks us which among the following four options are valid actions. Okay, so which of these do you think are valid? You can feel free to use the chat box to post your answers, or you can unmute yourself and speak up as well. Okay, while people are answering the question, there was a question by Aman on how will this course impact a student's career who is taking the course. Okay, so that's a good question, first of all, and a very relevant question. So I will say that okay, so many a times when you hear about these deep learning methods and machine learning methods, well, machine learning is mostly explainable, but there are many things in deep learning that still are unexplainable, right? They are mostly black box. Here we are dealing with simplistic approaches that have proper algorithms planned for them, right? And any problem that you solve, that can be solved along with its corresponding interpretability and explainability. So that is one added benefit of learning these algorithms or methods that you will encounter in this course. You will understand from the very basics about problem solving. Okay, that is one application, and that will be a useful skill to apply to more advanced problems that you encounter in other courses like deep learning or machine learning or generative AI or things like that, or NLP, right? And then many of these methods later on, or approaches later on, have these search methods that you are learning as sub modules and in the back end, right? For example, in ChatGPT, when you post, I hope all of you have used ChatGPT, right? Have you? Can I have a show of hands? Okay, many of you, most of you have used ChatGPT. Great. So as you see, when you ask ChatGPT a question, it gives you a certain sequence of words, right? It gives you a text that is a sequence of words, right? Many a times that also in the back end uses search methods, or might use search methods, right? And it will be beneficial to learn some of them, so that maybe in the future, if you design some approach of your own, you can see if some of the methods you learn over here could be put as sub modules over there, right? So that's all I would say, and there are a flurry of articles available online. You can go through that and see how traditional and simplistic AI approaches could complement the more modern and state-of-the-art AI approaches. Okay, coming back to the question. So which of these are valid actions? Let's go through the options one by one. Okay, so the first option says that put down M. Okay, so put down M basically means putting down M on the table, but M is already on top of this box I, right? So would that be called a valid action? No, right? Because it's already on top of another box, so you can't put it down on the table given this initial state. Maybe in some other state you might be able to do that. Okay. Then the second option is pick up V, that is on the table. What do you think about this? we can do that, right? Because it's on the table, the robot's arm is empty, it can just pick up V, right? So pick up V is valid. Stack Y on G. No, right? Yeah, you have to have the stack, you have to have the box Y in hand for it to be able to put on G. Okay, and the final is unstack R from O, which can be done because it's on top of O and you can just use the robot to pick it up. Okay, so the correct options are pick up V and unstack R from O. Okay, I hope that was clear. Okay, great. If you have any doubts, please feel free to use the chat box to let me know, or you can speak up and let me know as well. Okay, so in the previous question, we did not say anything about how much time it takes to perform a certain action. Okay, but in question 2, we want to specify that. We say that if a pickup and an unstack action takes 2 units of time, and a put down and stack action takes 1 unit of time, then what is the shortest time in which you can go from the initial state to the final states, and you won't be taking any breaks in between? So what you have to do is use these 4 actions, come up with a strategy of going from initial state to final state following a set of actions, and you have to give me the optimal set of those actions, a sequence of those actions that gives you the final state in the shortest possible time. Okay, so I'll let you think about it for a minute and then we can have a look at the solution. Okay, in the meantime, if you have a solution, please feel free to contribute or speak up or post it in the chat box. Okay, I'm back. Okay, so there are a couple of questions or messages in the chat box. Pick up and unstack and put down. Yes, but we'll have to specify which boxes we want to pick up and unstack and put down. Matthew, is the audio working now? Maybe you can try removing your audio device and connecting again. I wouldn't say rejoin because we already are at max capacity, so I don't know if you disconnect from the Google Meet if you'll be able to rejoin. So I hope it gets resolved. Is the audio clear for others, or is everyone facing the problem? Okay, I guess it's working for everyone then great. Okay, so we have a couple of answers. Let's have a look at the solution. So the optimal time is actually 24 units, and let's see how that is done. Okay, so the first thing that we will do is we will unstack this box M from top of I. Okay, that will take 2 units of time. Okay, now we have box M in our hand, okay, or in the robot's hand, and what we can do, we can we put it directly on top of the V box?
No.
No, no, because we want to put I on top of V, and if we put M on top of V, we'll have to go some additional steps, right? So we'll just unstack M, put it down on the table, and then unstack I, and then stack it on top of V. Okay, so that will take, so the first operation will take 2 units, put down will take 1 unit, unstacking I from B will again take 2 units, and then stacking on top of Y on V will take 1 unit. Okay, so that was the first few things that we will do. Now we want to stack B, right? Note that B is now free because we have removed M from top of it, I also from top of it, so we can just pick up B and then stack it on top of I, right? And that will take 2 units and 1 unit of time. And similarly you can proceed with the other boxes as well, and eventually you will see that once you reach the final state, if you sum up all these times, it would come up to 24 units. I will leave this on here for a minute so that you can cross verify your answer with the available solution, and if you have any doubts, please let me know. If not, we will move on to the next question.
So I think we can move on.
Okay, great. Yeah. Okay, so I hope this was clear. Let's move on to the next question. Okay, same problem statement again, but a different question about it. So let's say that the plan that takes the least amount of time to achieve the goal is the best plan. Okay, the plan that we just saw in the previous question. Assuming that we don't care where the block W lies, once the final state is achieved, which is a desired arrangement, where would it be lying once we execute the best plan?
The table.
That's right. It'll just keep lying on the table, right? Just beside this arrangement that we have, and we will have this M over here as well. Okay, so this is just to kind of indicate to the point that once we have arranged this once we have reached this final state, the elements of the problem or the domain that were not involved in this particular arrangement, they remain as is because you are not touching them, or you touch them and then you let them be as they are. Okay, so this was straightforward question 3. Let's move on to question 4. Now we change the context slightly. Okay, and this is one figure that you may have come across in the lecture videos that you might have seen in the initial few weeks, right? So can you recall this picture from the lectures, and can you tell me in what context this was used?
Answer A.
A, right, to express the richness, ambiguity and the impreciseness of natural language. And yeah, actually it's only A, none of the other points seem to make sense. And would anyone like to say what exactly this picture is trying to convey?
So here in this, a policeman was guiding someone with the
Mm-hmm.
directions, what with the picture in his mind. Okay, but exactly the other person may not be knowing the world around him. Okay, but he would actually know only the directions which were given. So, but that may not be clear because the language someone is expressing may not be understandable by the other person in the same context.
Exactly. That has been very beautifully explained by our friend Vijay over here. So thanks Vijay, and that yeah, I won't contribute anything else to it. This is exactly what I wanted to convey as well. So any doubts here? I hope not. This is a pretty straightforward question. Okay, great. So maybe let's move on to the next question then. Okay, so now we are going to see a couple of questions of similar type, okay, where we are given a sentence in the English language, okay, and we have to say what certain specific words refer to, okay. So here the sentence that you have been given is: Elizabeth told Lily that she scolded her because she was in a bad mood. Okay, so notice that she appears twice in this sentence. Okay, and I've color coded them. One is colored red and the other is colored green. So we have to decide who exactly among Elizabeth or Lily do the red she and green she refer to, and I'll let you think about it.
Answer B.
Answer B, Elizabeth and Elizabeth.
Elizabeth and Elizabeth. Okay, so there are a couple of answers. Some are saying A, some are saying B. So this question actually relates to the question that we were discussing previously in question 4, wherein there is a ambiguity in natural language. Okay, we can interpret this sentence in a number of different ways. The first way we can interpret it is: Elizabeth told Lily that she scolded her. That is, Elizabeth scolded Lily because Elizabeth was in a bad mood. Right? Elizabeth was in a bad mood. That is why she did the scolding. In which case, in which case, both the she will refer to Elizabeth. But there can be another interpretation, which says that Elizabeth told Lily she scolded her. Elizabeth scolded Lily because Lily was in a bad mood. Maybe Lily is a child that is misbehaving because she is angry or in a bad mood, and Elizabeth is her mother and she tried to school her by trying to scold her, which I don't want to comment on whether that is good or bad, but let's just assume that this is the sentence given to us, this is the situation, and in which case the two she's will refer to two different people. Okay, and we can even switch the order. You can also say that Elizabeth told Lily that she scolded her. Lily scolded Elizabeth because Elizabeth was in a bad mood. Maybe it's the kid complaining to her mother that you scolded me because you were in a bad mood. Right? So the way we interpret the sentence can lead to different assignments to whom this word she refers to. Right? So actually the answer is we cannot say, because we cannot resolve who exactly this she refers to, because there is an ambiguity in this particular sentence. Yes, Vijay, this is we are going towards Vinograd schema, and then in the next few questions we will encounter a few more examples of how to do this anaphora resolution in Vinograd schema. So was this question clear? That is in why we cannot say. Okay.
No, but naturally, like if someone understands this English, they would assume that in both the cases she is referring to Elizabeth only. So why we cannot, determine here? If it
No.
is a,
Yeah.
because if you follow grammar, like if you put comma and all those things, then definitely we'll be able to make sense. Who's scolding whom.
Um, yes, I mean, yes and no. I mean, yes, punctuations definitely help us. Here, unfortunately, we are not given any. Um, and in mostly when we talk to each other, we don't talk with punctuations, right? So, especially in art, like in speech conversations, this is, I would disagree that this is easy to interpret, because how we emphasize each word can lend to different meanings, um, and this is just to point out that there is some ambiguity in in the way we frame certain sentences. There are some sentences in which we can very clearly say what a word refers to, and we will see some examples of that. And yeah, there it's very specific, very clear. But then there are some cases where we have some ambiguity and some uncertainty, and that is actually the richness or the quality of natural language. Okay, I
Okay.
hope, yeah, thanks for pointing that out. So let's move on to another question. And yeah, so I think this will address something that some uncertainties that we had faced in the previous question. Here it says Elizabeth told Harry that she scolded him because she was in a bad mood. So here, whom do you think she refers to?
Both Elizabeth.
Both Elizabeth, right? Because here it is very clear that she refers to a female, and the only apparent female name from this sentence, yeah.
Sir, answer B. LGBT respectively.
Sorry, I couldn't get you. Can you come again?
Answer B.
Answer B. Yeah, that is correct. Correct, Sadev. Yeah, so just like I was saying, that here the only apparent female name in the sentence is Elizabeth. So we can conclude that both the she are referring to Elizabeth. Okay. So answer B is correct. Yes, there can be cases where Harry is also referring to a female, but usually that doesn't happen. So we will just assume that we won't go into too many complicated situations. Okay. Okay, another question of similar type. The Millennium Falcon overtook the Imperial cruiser because it was too fast. So, what was fast?
B. Millennium Falcon.
Millennium Falcon, right? Because that is the ship that is doing the task of overtaking, right? And it can overtake only when it is faster than the other ship, right? So here it clearly refers to Millennium Falcon.
Answer B.
That's right. Answer is B. Now, if we just change one word from this sentence, instead of fast, we say slow. The Millennium Falcon overtook the Imperial cruiser because it was too slow. Now, what was slow? What is it referring to?
The Imperial cruiser.
Imperial cruiser, exactly. So here it refers to a different ship because we are attributing another quality to that, right? So the answer is Imperial cruiser, which is option A. And these are some examples of anaphora resolution as per Vinograd schema, right? Yeah, question 9 is already answered. So the last few questions involved anaphora resolution. Okay, then. Now let's come to an interesting problem. Okay, the water jug puzzle. Oh, how many of you have heard of this puzzle before? Okay, there are a couple of you who have heard this before. Yeah, I would request that if you don't have a question, you can please mute yourself so that it won't affect the rest of the session. Or maybe I will mute you. If you have a question, please feel free to unmute yourself again. Okay. Okay. Okay, so a couple of you are already familiar with the water jug puzzle, which is great. But for the sake of everyone, let me just go over what the problem is. Okay. So as the name suggests, we have 3 water jugs. Okay, that have different levels of water in them. Okay. There are some rules to this puzzle. Okay. Some of them are that you can only either completely empty the jug, you can pour from one jug to another, okay, but you can either completely empty a jug or completely fill a jug. Okay, you can't, let's say if you have 7 liters of water in one jug, you can't just take out 2 liters from it and then put it in another jug. Okay, you can only either completely unfill it or completely fill it. Okay, and then
We can use 7 liters, 5 liters, and 2 liters jig.
sorry.
We can use 7 liters jig and 7, 5, 4.
You're referring to the capacity of different jugs. Yeah, that's what I was about to get to next. Each jug has specific capacity. So
So
the
the
first
answer
jug
would be
on
2,
the
sir. The least number of transfers. within
It's
two
two.
transfers,
Last
we
two.
can bring it to 151.
Okay, that is great. If the answer is 2, I don't know what the answer is, but let's try to solve it. But let's keep 2 in mind, okay? But just for the sake of completeness, I'll just put forward the problem and then we can go to the solution of it, okay? Okay, so yeah, each jug has a specific capacity. The first jug on the leftmost side is of 7 liters, the middle jug is of capacity 5 liters, and the rightmost jug is of capacity 2 liters. Okay, and this is one instance of the water jug puzzle problem. There can be other instances where jugs have different capacities. Okay, and this is the initial state given to you on the left hand side. Okay, you represent each state as a tuple, indicating the amount of water in each jug. Okay, so for example, the first state, the leftmost jug has 7 liters and the other two jugs have 0 and 0 liters of water, so you represent that as 700. Okay, and the final state that you want to reach, the goal state, is 151. Okay, so you want to go from the initial state to the final state, and yeah, that is the problem. Now let's see what are the actions that you can take to go from the initial state to the goal state. And for that, I will show you what we call a state space graph or network, but I'll go over the answer, so please close your eyes if you haven't solved it yet.
Six.
Yes, but let's look at how we achieve that. Okay, so we are at this 700 state. Okay, I hope you can see my cursor. Is my cursor visible?
Yes.
Okay, good. So let's say we go from 700 to 502. Okay, and how we do that is by pouring the leftmost jug into the rightmost jug until it's full, right? So because the rightmost jug is of 2 liter capacity, we can only transfer 2 liters from the left to the right one. And if you minus 2 from 7, we are left with 5, so we are left with 502. Okay, from 502 we can go to 520. Okay, wherein we transfer 2 liters from the rightmost jug to the middle jug. Okay, and then we go from 520 to 322. We again transfer 2 liters from the leftmost jug to the rightmost jug, and then we again transfer water from the rightmost jug to the middle jug, which leads us to 340. Okay, and then we again repeat the same process. I think there is an echo. Can you mute yourself? Yeah, thank you so much. Again we transfer 2 liters from the leftmost to the rightmost jug, leaving 142, and then finally we transfer 1 liter of water from the rightmost jug to the middle jug. Remember that we can transfer 1 liter only because we are letting water in the middle jug fill up till it's full, and because the middle jug was already at 4 liter capacity, it can only accept 1 more liter of water, and that's how we are able to transfer 1 liter from the rightmost jug to the middle jug, not by us measuring but by following the restriction that were given to us in the problem. That's how we go from 700 to 151, and let's see the number of hops that we take. Okay, so first we went from 700 to 502, which is 1 hop, 2, 3, 4, 5, 6. So 6 steps we took to go from initial state to the final state. And if you look at the different arrangements of the waters in the different jugs that could be possible, I think one of the answers is already available on the screen is how many different states could exist. Okay, that is 14, right? There could be 14 states that could exist that you could reach from the initial state. But if there was some other initial state, let's say there are 4 additional states, okay, that are not reachable from any of these states on the edges, but you could reach some of these states on the edges from these internal 4 states. So there are in total 18 states possible. Okay, and I'll let you verify that by yourself. Okay, so I'll let this screen be on here for a minute. If you have any doubts, please let me know. Can I explain the concept once again? Is the problem clear to you? Should I go over the problem again or the solution?
Both, sir.
Both? Okay. Okay, let me try to use a whiteboard to better explain things. Okay. Can you see my screen? Can you see the whiteboard? Okay. Great, great. Thanks for confirming. So what you are given is you have 3 jugs. Okay. Each of them have different capacities. This is a 7-liter jug. This is a 5-liter jug. And this is a 2-liter jug. Okay. You are given a specific arrangement of the water level in each of these jugs in the initial state. So let's say that this is the initial state where the leftmost jug is completely filled up with water. Okay, that's completely filled up with water. So this is 7 liters. The middle jug is completely empty. So this has 0 liters of water.
Completely data.
Sorry, is there a question?
Sir, it has 5 liter, right? So
No,
completely empty
that is the
also.
capacity. That is the
Yeah,
maximum
got it,
amount that
got
we
it,
can fill it in, but it doesn't
got it.
have any water in the initial state, in the state we are beginning with. Yeah, but thanks for clarifying that, or helping clarify that. Similarly, the rightmost jug is also of capacity 2 liters. That is maximum we can fill in 2 liters of water there, but currently it doesn't have any. So the initial state that we are starting with is 700. Okay, is that clear?
Yeah, clear.
Okay, now we want to see how we can achieve the state of 151, where the leftmost jug has 1 liters of water only. So it will look something like this, only 1 liter of water. The middle jug has 5 liters of water, it's completely filled up. And then the third jug has 2 liters of 1 liter of water again. Okay, mind that the capacity is still the same. This is okay, this is supposed to be a slightly bigger jug. So this has capacity till, let's say, 7 liters. This is capacity till 5 liters, and this is capacity till 2 liters. Okay, so this is a slightly shorter jug. Okay, this is how it will look like in the goal state. Okay, one of the things that we will do is, let me also erase this capacity from this thing so that it's easier for you to understand. Okay, now in the initial state this was completely filled with 7 liters of water. So the first thing that we will do is we will pour water from this to this jug. Okay, maybe I should also represent this proportional heights.
So that we understand, but only thing is the whole 18. How did we arrive at, like, from state 7002 151 we reached in 14 steps, right? And
No, we
something.
reached it in 6 steps,
6 steps, correct.
But the total number of states is 14. That is something that was part of another question that was not relevant to what is the shortest solution to go from initial state to final state, and that you have to come up by exploring the state space. Okay, there can be several configurations of water in the different jugs given the problem rules and restrictions that we have, and given a certain initial state, you have to explore what are the different states one could reach to given a particular state. So if you are in 700, you have to find out which are the different states that you could reach from here. One of those states is 502. One
So
of those
could you
states,
differentiate between steps and states, because the both terms refers to same, right?
no, um, each node over here, each arrangement of water in the different jugs is a state. Okay,
Okay.
each action we are taking to grow from one state to another state is an action or a step or an edge in this graph. Does that clarify?
Yeah, okay. Yeah.
Okay,
And how about step?
that is a step.
Okay, state is?
State is one arrangement of water in the different jugs.
Alright, okay. Yeah,
Okay.
got it.
So 700 is one state, 052 is one state, but one step is going from one state to another state via some action that was allowed to us in the problem statement. Okay.
Yeah, okay, so thank you. Yeah.
Okay, thanks for the question. Yeah, so I was just saying that you could go from 700 to 502, in which case you would be transferring 2 liters of water from 7-liter jug to the 2-liter jug. Another state that you could go to is 250, in which you could instead transfer water from this to the middle jug until it's full, right? So this gives you 2 different states that you could go to from 700. Again, from 502 you will explore what are the different states that you could go to, and this is how you will keep building the graph, and this is how you will come up with those 14 states. Okay, don't worry about the 4 additional states that were mentioned in the graph. Those were just mentioned due to some doubts that were raised in the previous iteration of the course that was offered, and I've just kept it for the sake of completeness. Okay, was that helpful? Does that clarify your doubt, Vijay?
Yes, you did. Yeah.
Okay, great. So I'll go back to this graph that we had. Okay, and so this is a very simple problem. Okay, we have very few states in the whole state space. Okay, so state space, if you cannot recall it from the lectures, is the collection of all the states that exist in the context of a problem. Okay, and it has very few state spaces, very few states in the state space. There are only 14 or 18, let's say, states. In real world problems, this number of states would explode exponentially. Okay, that is where having methods or heuristics to solve the search problem to go from one state to another would be helpful and efficient. Okay, that is one motivation or an example of how you can scale things up. Okay, so I hope this part is clear. Any remaining doubts here before we go through the rest of the questions?
No, sir.
Okay, great. Then let's just go over the different questions that we had. I think most of that we would already have answered, but still, let's go through them. So starting from 700, what is the least number of transfers or moves or steps required to reach 151? So the answer is 6. Any doubts there?
No, sir.
Okay. Okay, starting from 151, what is the least number of moves required to reach 700? Now you want to go from the goal to initial state.
2.
Sorry?
2.
2. Okay, let's verify that from the figure. So you are at 151. Okay, yeah, you basically just transfer everything to the leftmost jug, right? That's how you achieve it.
Yeah.
Yeah, exactly. So that is 2. So see, depending on where you start, the number of optimal steps might differ. If you're um, because you were going from 700 to 151, the number of the optimal step followed optimal, sorry, I'm misusing some terms. The optimal search path followed 6 steps in this case. But if you start from 151 and you want to go to 700, the optimal path will require only 2 steps. Okay. 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 Then the next question was, how many paths from 151 to 700 have minimum length found in question 11?
1. Over here.
Okay, let's have a look. There are 2 ways.
So could you tell the logic for this?
Yes.
Minimum.
So the way we get 2 steps. So one is the way we discussed, right? We transfer 5 liter to the one leftmost one, then we transfer 1 liter to the leftmost one. Is that? Do you agree with me on that? That is the correct path.
Yeah, yeah. But minimum length.
Minimum length is just the optimal path, containing the least number of steps to go from one step to another.
Okay, fine, fine.
Okay.
Got it, sir. Okay.
Okay. Thanks for your question, Nasima. Yeah. So the way we have 2 paths here is, the first path is where we first transfer the 5 liter to the leftmost and then the 1 liter. So that will lead us from 151 to 601 and then from there to 700. The other path is where you just reverse the order, right? We pour the rightmost to the leftmost, so that will go from 151 to 250 and then 700. That gives us 2 optimal paths. Does that help understand or clarify?
Yes, sir. Yeah.
Yeah.
Okay, great. What is the size of the state space or the number of states in the 752 water jug puzzle? We just discussed that. It's 14 or plus 480. So again, don't be worried about this thing, okay? If you are asked a similar question in another problem's context, you just follow what is most apparent and most appropriate to you, okay? If there is any ambiguity in the solution, like in this case both 14 and 18 seem to be correct solutions, you will be awarded marks for both. Okay, so just clarifying that. Okay, then okay, so the question on how did we go from 152 to 142 to 151? How did we measure 1 liter? So a great question, Rajat. So that's where the rules of the problem come in handy. Okay, so in the beginning we had specified that the only way to make a transfer is either we keep pouring water from a jug to another jug until the jug from which we are pouring is completely empty, or the jug to which we are pouring is completely filled. Okay, in 142 the middle jug is already having 4 liters of water, so it has only 1 liter of capacity left. Okay, now the rightmost jug has 2 liters of water. We cannot measure 1 liter from this, but we can keep pouring from the rightmost into the middle jug until the middle jug is completely filled up, and the middle jug will be filled up only when 1 liter of water is exactly transferred from rightmost to the middle one. And just at the point when the middle jug is completely filled up, we know that we have transferred 1 liter. Okay, so that's how we are doing it. Okay, I hope that answered your question. Okay, so this was one instance of the water jug puzzle, okay, where we had 752 capacities. You can try out different capacities. So I would suggest one homework exercise, if you will. Take different capacities of these water jugs, okay. Maybe you can look up some solved capacity problems in on the internet, because then you'll be able to verify yourself, because the answer would be available, okay. And then try to come up with a similar state space and another optimal path starting from any one of the states as the initial state, any random state, okay. So that will be a good exercise, okay. And if you have any doubts, please feel free to let me know in the next live session, or now if you have it.
So like this, we have created a state space, and then we arrived at the count, right? Number of
Yes.
states.
Yes.
Is there any mathematical formula for this? Like, so that we'll get to know.
The number of states possible given a particular
Yes.
arrangement.
Yeah.
I can't recollect any formula right now, but I would encourage you to find out.
Okay.
I will also try to look it up. If I find something, I'll let you know in the next live session. But as of now, I can't recollect any formula. It also depends on the problem. Sometimes some problems have very apparent formulas. Here I'm not sure. Okay, they may or may not be. It's better to ask the internet.
Okay.
Okay, thanks for your question.
I have a question. Inside the shape, there are a number of arrow marks is shown. What for it is shown, and
Yeah.
is there
Okay.
any reason for that?
Yeah. So basically, the arrow marks mean the direction of the arrow mark means you can go from one state to another. Okay. For example, here you have 610. Okay. From 610, this gray arrow, if you follow, this leads up till 250. Okay. This means that you can go from 610 to 250.
Those also should be taken into count, or just it is shown
No, it's just
in the shape.
showing how you could reach from one state to another. Okay. You don't need to take into account all of that when you find the optimal path. When you find the optimal path, you can just follow one. You can just draw bold lines that like what is shown over here. From 700 to 502. Okay, actually, it's good that you raised this point, because this unidirectional arrows show that you can go from one state to another, but not from the above state to the below state, right? Here, for example, you can go from 610 to 250, but you cannot directly go from 250 to 610. Do you agree with me?
250 to 610.
Yes.
Yeah, we cannot reach it.
We
Correct.
cannot reach it, right? But we can go from.
It is not reversible.
Exactly. So this one directional arrows say that you can go from one state to another state only in that direction, whereas these bold edges represent that you can go from one state to another in both ways, bidirectionally. Okay.
Sir, I have one doubt.
Yeah.
How 511 state goes to 412 state?
How does?
It 511 initial state, sir, and it goes to final state 412. How it's possible?
Yeah.
Final state, from you starting from the initial state, right? 700, and then you want to see it goes to where? Sorry, can you can you tell me a question again? I suppose you are typing it on the chat box.
No, I think her question was on the left side, like, you have 412, right? So it can be derived from 511. So how is it possible?
412.
No,
Where
on
is?
the left. Yeah, that one.
Okay,
If
it can be derived from 511. Yes.
511 to 412, how is it possible?
511 to 412.
So it's
Yes.
nothing but they have poured 1 liter to the left jug. That's it. Sorry, right jug.
Yeah, exactly.
Yeah,
So you
that's right.
had 2 liters in the rightmost, and then you poured 1 liter. Uh,
No, no, the reverse of it. From 511,
mm-hmm.
actually, the from 5 liters, it was poured to the extreme right one, which is having a 2 liters capacity. So that's how 412 has come from 511.
1 liter is already there, so it can
Yeah,
occupy 1 more liter.
1 more liter. Yeah,
Okay, but we are going from 511 to 412, right?
Yes,
Okay,
yes,
so we
yeah,
are
yes.
emptying one. Exactly.
yeah.
Yeah,
That was the question.
yeah. Oh, so thanks for answering that. I hope that's clear. Yeah, thanks to all those who got that. Sometimes we just have a brain freeze. That's what happened with me. But yeah, thanks for the question and thanks for the colleagues who took that up. Anything
Yeah,
else? Mm-hmm.
could you please provide me that PDF? Sorry.
Sorry, can you come up?
Yeah,
Can you say your question again?
yeah, could you please send me that PDF?
This PDF will be made available along with the recordings. Okay, so I will supply it to the NPTEL team, and the NPTEL team will supply to all the registered students. Okay, so I cannot directly send it, but what I can do is maybe to the attendees here, I can just give you the um, link of the common folder, and then for the others, you can either watch it in the recording or it will be made available. Just give it a week's time, it will be made available to you. Okay, so I posted the folder link in the chat box, you can just follow that.
Yeah, got it. Thank you so much.
Okay. Okay, where were we? Okay, anything else here? Okay, so a couple of messages in the chat box, let me quickly address that. Okay, someone shared their contact. I would highly encourage, please don't, because this is a public forum and it will be uploaded on YouTube. uh, unless you are comfortable with that, um, I would personally advise against it. Okay, because this will be visible to everyone all across the globe. Okay, and about WhatsApp groups, so the official mode of communication for the course is uh, through live session and the discussion forums. Okay, you can feel free to create a WhatsApp group, but that will be unofficial and none of the instructors or the TAs will be a part of it. Okay, so we would encourage you raise your queries or your questions through either the live session or the discussion forum, so that others can also see the queries and maybe they will be also having similar doubts and they can also chip in. Okay, so that's all we will say. That is the official communication, but it's up to you. You can join or not join any WhatsApp groups, they will be unofficial only. Okay, and I don't have any group. um, Okay, Mayank, similar answer to the question that Vijay was asking initially. I am not aware of any formula to find the number of states in this particular problem. There might exist one, but I am not aware of that as of now. I'll try to find it. If there exists one, I'll let you know in the next live session, or you can in the meanwhile also search yourself. Rudra, I will upload the session maximum by tonight, midnight, but when it will be communicated to you, that is in NPTEL team's hand. I cannot interfere there. Usually they take maybe around a week or so to set everything up, because this is just the first week of the course. Once it is set up, you will be getting access to the recordings instantly, just the day when the session ends. Okay, but just for the initial week or so, you have to wait for maybe some time before you get access to it, and the deadlines will also be there accordingly. I think because this is only the first week, you will have enough time to solve the assignment, the first assignment, so don't worry. Yes, Adnan and Sarika, both your queries, both your messages, I do see that, and unfortunately, there's not much I can do. This is the limit set on Gmeet. Um, yeah, all I can say is that this is currently being recorded and I will upload it by tonight itself. NPTEL team might take some time to put it up on the Swayam portal. I can also point you to where exactly you can find the link once it is up. Okay, so over here on the Swayam portal, okay, on the left hand side you see these different columns, right? Week 0, week 1, week 2, download videos, books and everything. In some time the NPTEL team is going to add another section over here called the problem solving session. Okay, and there you will have the link to a Google Sheet which you can access. Okay, and that will have link to each recordings for each session, and I will keep updating that as the weeks progress. What I can do right now is I can point you to the YouTube channel where it will be uploaded, so maybe that will help. There are previous recordings available over there as well. Okay, and yes, this is it. There you go. So this is the link. If you just search my name and then PMRF, you can find the YouTube channel easily, and it has the recordings from the previous sessions as well. This current semester's current offerings recordings will be made available soon. Just be a bit patient, just give it a week or so, it will be made available. But in the meantime, you can re-watch the previous sessions recordings.
Sir, our recordings are related to this course only, right, sir?
On the
Artificial
YouTube channel?
intelligence. Yeah, on your YouTube.
No,
Yes,
there
sir.
are two courses, but you can find it. There are playlists arranged. You can just look up the playlist and you can find the relevant course.
Oh, okay, sir.
Yeah. When is the next live session, Aditya? It will be on Tuesdays. So every live sessions will always be on Tuesdays, 6 to 8. Okay.
Yeah. Okay, sir.
Okay. Okay. So that was logistics. That is done. Let's go back to the questions. So water jug is done. Okay. Now I would like to introduce you to another problem, the missionary cannibal problem, and I won't solve it, but I will encourage you to try to solve it. And if you face any difficulties, we can discuss it in the next live session. Okay. So essentially, the problem is that you have a river. Okay. And you have a boat. Okay. And you have three instances of people. Okay. The first instance is M and the second instance is C. The difference is that C can eat M. Okay, there are several variants of this problem. Okay, in which C could be represented by a tiger, M could be a human being or a sheep or things like that, or a goat or things like that. Okay, it has several names. The point is that C can eat M. Okay, C can kill M, and you don't want that. You can transfer people from one side of the river to another side, but that has specific rules. Okay, you can transfer one at a time. Okay, so only one person or one individual or one animal at a time can be transferred, and you have to make sure that you are not in a state where at the other end of the river the cannibal is overpowering or outnumbering the non-cannibal or the missionary individuals, so that they can eat them or kill them. Okay, this is a high level view of the problem. There are details that I am not going into right now, but you can look up this problem. It's a very well written page available on Wikipedia and several other articles. Go through the different rules that are applicable to this particular problem. Each problem in these problem settings will have very specific set of rules and you must adhere to them. Okay, so I gave a very brief overview or a very high level view of the rules, but you go into the details, see the specific rules, and then try to come up with a similar state space first of all, and the number of states, and the directionality from one state to another, similar to what we did in case of the water jug problem, and then you try to find the optimal path from this initial state to the final state. Okay, you try that out yourself and you can let me know in the next live session, we can discuss it. Okay, so that brings me to the end of questions I had for today's session. Okay, these are the acknowledgements. Okay, do you have any specific question that you would like me to discuss? To address the one question in the chat box, I would recommend if you post your question on the live session or the discussion forum, because I don't regularly check the YouTube channel. I will try my best, but then I would prefer if you raise the queries either through the live session or the discussion forum, so that it can be addressed easily. You can post it on the channel as well, but then I will check it less frequently. So to get faster to your query, it's the other two channels are recommended. The other two ways of conveying your query is recommended. Okay. Anything else that you would like to be discussed? Any general query about the course or the live sessions or anything to do with the course? Okay, so Mayank says that question 14 is a flash game that I played in my old computer. That's great. Many of these problems actually have fun implementations. So actually I would suggest something. How many of you are familiar with Pac-Man? You remember Pac-Man? There was one round figure that used to eat stuff while it went through a maze. Yeah, some of you are. So if you actually put Pac-Man into a maze, right, and you have food spread out at different points of the maze, and you also have ghosts in the maze that can eat up the Pac-Man, this is a very interesting or a very good example of a fun area where you can implement search methods. Okay, you can actually design a maze. You can put Pac-Man into any initial point. You can point out the foods, where the food are situated, where food is situated, where the ghosts are situated, and you can point out how exactly the Pac-Man is allowed to move, and based on that you can apply the different search strategies that you will learn eventually in the different weeks of the course to solve that problem. Okay, that is one simple game. You can apply it to several other games as well. Yeah, Adnan, you had a query. Please feel free to speak up.
Yeah, as there was a videos in YouTube which was uploaded 3 years back, 4 years back with same course. Is that comes under like current this course? So I mean,
Yeah. So this course is essentially offered every other semester. So between July to November, it is offered all every year, right? So there are multiple iterations of the course. So the 1 year back, 2 year back, 3 year back recordings that you see correspond to each of those offerings, and the questions are same. So you can just watch any one of them.
yes, okay, okay.
Yeah. How AIs are working with the black box? That is a very good question, and what majority of the AI community is after. There is a whole new area of research now called explainable AI, where they are trying to unfold the black box and see how exactly they are producing the results that they do. Yeah, it's an open question, and no one really knows. People have some clues, but yeah. It's still an open question and open to research. There are some methods that are very explainable because they follow very simple strategies, and any outcome that they arrive at is explainable. But I mean, you can try to unbox that in some ways through the mathematical underlyings. For example, in a neural network, you know what are the operations you perform at each step. Okay, this course is not about neural network, just clarifying, but you know the exact mathematical operations that happen at each step in each of the nodes, each of the layers, right? So you can try to somehow look into that and see how exactly things are growing or things are changing, and see how certain features are resulting in certain outcomes. But there are a lot of models that are still black box, and majority of them are black box, and yeah, it's an active area of research. Can I recommend any AI course? Depends on your interest, Mayank. There are so many courses these days. If you're interested in natural language processing, you can go for NLP. If you are interested in computer vision, you can go for that. If you just want a basic introduction to the different pattern recognition and traditional ML based techniques, you can go for Introduction to ML course. There is a course by Professor Ravindran of my institute itself. That's really nice. I have taken that. So yeah, it depends on your interest. You can explore the set of courses being offered on Swayam, and then depending on your interest, you can choose any combinations of them. And this course, of course. Okay, we have a suggestion from one of your friends. Priya says programming with generative AI looks interesting. Yes, Adnan, you can refer to my videos posted from the previous iterations. The only difference is the kind of doubts that are raised in each year. Some of these do overlap, but each student is unique, right? So each time you have different set of questions, different set of doubts, and that's the only difference. The question answers and the explanations are the same.
So one suggestion I have, it took me nearly 20 minutes to join the session.
Yes.
It was not letting me in, and one of my colleague is still trying. It says the classroom is full and she was not able to join even till now. So by the next week at least, would you resolve this issue so that we can get into the session from the beginning of the session?
Yeah, thanks for pointing that out, Seema. I'm aware of that. So one issue that happened at the beginning of the session was a technical issue. I was trying to join the meeting. I am the host of the meeting, but then it was not letting me share my screen for some, I don't know, random reason. So I had to restart my system, and that killed some of the time. And the Google Meet has an inherent capacity of 100 participants. That is something that unfortunately I can't resolve. So the only way to address that is to rely on the recordings if you're not able to join this meeting. But usually the trends that I have observed in the previous iterations of the course, maybe, I don't know, I've taken the live sessions for the past 2 or 3 semesters. In the first 2 weeks or so, we have more than 100 attendees, but then these numbers taper off to somewhere around 20 or 30 or 50s. So
Yeah,
That
someone
won't be
told
an
me
issue
that
in the next
in
week, is it? Okay. We'll
yeah,
check, sir.
so
Sir,
it'll eventually taper out.
even
And
in my mail ID also I tried to connect, but it doesn't let me in, sir. So I use different email ID to connect it, sir.
okay,
So not
maybe.
about different mail ID. It's showing that max people have been reached. No matter you try from different mails.
Yeah, maybe you were able to join from the other ID just when someone left. So you just filled in an empty space. So that's why you were able to
Yeah,
join in.
and sir, someone told me that in Microsoft Teams have more limit compared to Google Meet. Is that right? Or else?
I know. There are other Teams is there, Zoom is there, many other stuff is there, but because in my experience this problem doesn't really bother us after a week or two. I haven't really tried those other platforms, and also once the link is set for one semester, usually the same link is followed for the rest of the weeks, so you have to join the same link for each week. So changing this right now would lead to a lot of logistical corrections, and I would not encourage that. So yeah, the worst
And
case
yeah,
scenario is that you are not able to join the meeting and then you can access the recording later on. So that is something that could be a solution. But yeah, please go ahead. You were saying something.
and you upload a video of live section in next working day. It's not worry about.
Yeah.
It's okay for us.
Yeah, that's comforting to hear. I'm aware that the deadlines are usually set on Wednesdays, so that's why the session is happening on Tuesdays. And like I said, I will upload the recordings each day by midnight. And once the initial setup by NPTEL team is done, you will have access to the recordings as soon as it is being uploaded.
Yeah, no need to edit, sir. Just upload a thumbnail, then you can upload it. You can get a very good reach.
Okay, thanks.
So basically, this is not a corporate office, okay, where you expect everything to be done. This is driven by government, right? So there is a
Yeah,
department for it. Like, these people
got
actually
it.
present it for us and they'll be shared with them. And the department team personnel has to do an action from their side. And then it
Yeah,
will be
got it.
visible.
But
Yeah.
so many people like missing this concept, so that's
Yeah.
why I'm.
The other things like the teams and all, they are all linked to license. Like, there's a license one has to pay. But this,
Yeah,
is being open and it is allowing only 100. So that's the limitation.
Yeah.
yeah. Even I tried to join correct time, like 6 p.m. So it's like I have to join before 5.
I understand that, and actually, that problem has been conveyed to the team, NPTEL team, multiple times. And the only optimal solution that everyone could come up with is to just rely on Google Meet, because that is consistent. And honestly, in all of my experience, the problem tapers off. It doesn't exist in a week, in week 2 or 3 onwards. So let's hope for the best.
Yeah, it's just like any movie release. On the first few days, there will be heavy rush, and then after, you won't see any audience.
Exactly. Yeah. Thanks for your points, Adnan as well
But
as Vijay.
rather than watching the recorded session, here we would resolve our doubts. We can ask whatever our queries are, and we would get the solution on spot.
True, true. Uh, Again, like I said, hopefully that problem of not being able to join won't exist in the upcoming weeks. So,
Hopefully,
yeah,
yeah.
let's see.
Okay, so thank you.
Thank you. Thanks for all your questions. Um, Quantum technology, I don't know, Devraj. I am not the right person to answer that. I'm still doing my PhD. I don't, and I don't work with quantum technology, so I am not aware of any developments or specific developments. There maybe the major ones I might have come across in the news. Who knows? Maybe quantum technology might be the revolution of the next big thing. But who knows? Okay, so we have strayed too far. Anything specific that you would like to discuss from this week? If not, maybe
So
I'll.
I just want to ask one thing. Now,
Hmm.
the questions that we have discussed, would the assignment questions be very similar to this, like
Yes,
week one assignment?
yes, it will be very similar in the structure, as maybe not exactly same, as in you might have a water jug puzzle with a different kind of capacity of the different jugs,
Okay, yeah,
or you.
understood. But the concept wise, it would be same.
Yes, concept will always be confined to whatever you see in the lecture videos. So, whatever is covered by Professor Khemani in the lecture videos, we will ask questions only from that, not anything from outside that.
Okay, 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 sir. Thank you.
Yeah, thanks for your question. Um, Pramod, it will have rule-based systems. I think that is what you're referring to, I guess, by expert system. So yeah, that will be there. Okay. Um, Anything else that you would like to discuss before we end for today? Okay, if not, then thanks all for attending, and yeah, hopefully all the issues that we faced today won't be there in the next week onwards. But for today, thanks for attending, and let's meet next week. Have a good evening.
Good evening, sir. Good night.
Thank you.
Thank you, sir.
Yeah, thank you so much.
Yeah, thank you so much.